Okay, so today we're going to start our lessons on sequences and series. There is a difference between those two things, which I'll explain a little bit later. So try not to get the two words mixed up, although occasionally it does happen, but try not to. But a arithmetic sequence is something that you've seen before in GCSE and even before GCSE, where it's just a sequence of numbers, a list of numbers that all have a common difference. So in the two examples here, we've got a sequence of numbers where each subsequent number is 2 bigger than the one before. In the one below, our numbers are going down by 2, so each number is 2.5 smaller than the one before. Okay, and we're going to take this a lot further. So before we do, there are a few definitions, common definitions that we have to get used to, and a few letters that denote certain things. And we always denote the letter A as the first term. Okay, so in the first sequence there, A would be 5. In the second sequence, A would be 12.5. We use the letter D to denote the common difference. Okay, and that can be positive or negative. So in the first sequence, it's +2. Second sequence, it's -2.5. We say N is the number in the sequence. So it's a bit like we use the nth term. So the fifth term, n would be 5. The 10th term, n would be 10. And then the last one is we use this un to denote what the nth term is. So a few of you might think, well, that means that u1 is the same as a, because the first term, the nth term, is denoted as a, and it is. And I don't know why they decided to give it a different letter, but they did. Okay, so A is always the first term. Now, I know if you looked at that first sequence, you'd be able to write the nth term equation. But again, because of what we're doing at A level and what we're going to do a bit further on, we want to write the nth term a little bit differently, because we want to write the nth term using these letters here. So how can I write the nth term using A, D, N and UN? If I think about this, let's say I took the fourth term. The fourth term would be the first term plus, how many differences would I need to get to the fourth term? I'd need 3 differences. If I wanted the 8th term, again, I could start at the first term, and how many differences would I need to get to the 8th term? I'd need 7 differences. And this is where we get our generic nth term. We say our nth term is A plus, and if we look at the relationship between these numbers, you can quickly see it's n minus 1 differences. And this is the equation that we use. And we use this a lot more than actually working out that the nth term for this first sequence would be 2n plus 3. We tend to use this a lot more. And so we would say our nth term for that first sequence would be 5 plus 2 brackets n minus 1. Just put the d in front rather than after. Okay? Right, but we need to take this on a little bit. So there's a couple of useful things that we need to be able to do, and one of them is to find how many numbers are in the sequence 2, 5, 8, all the way up to 95, 98. Well, I always start off with these sorts of questions, whether it's arithmetic sequences or geometric sequences, which we'll do in a couple of lessons, the same way. I write down what I know, and I know the first term is 2. I know the common difference is 3. My last term, which is going to be my UN, is 98. And N is what I want to find out. I want to find how many terms are there, because that's U1, that's U2, that's U3, and we want to find UN, and the N will tell us how many terms are in the sequence. So I write my equation. a plus n minus 1 times d, and I substitute what I know. I know 98 is my nth term, my last term. My first term is 2, n minus 1 times 3, okay? And it's quite nice to just put that in front really rather than at the end, because we tend to write numbers in front of brackets. And it's a very simple equation to solve. Take away 2 from both sides and you get that, and then divide by 3 and you get 32 is n minus 1, so the number of terms is 33. And then you can even start doing it with things like this. Find the number of terms in the sequence that looks like this. But again, we start the same way. A, the first term is minus 4k. D, now what's the common difference in this case? What do I have to add each time? Well, actually, if I look at this one here, it's obvious D is 2k. But if it was a bit more awkward, how would I work out the common difference? Well, I'd just do this term, take away this term. Okay? Anyway, so we know our UN, our final term, is 100k, and n is what we want to find. We've got our equation. UN is the first term plus n minus 1 differences. So I've got 100k is the first term, which was minus 4k, plus n minus 1 times 2k. And again, I'm going to put that 2k in front of the bracket rather than behind. Okay, so add 4k to both sides and I get 104k equals 2k times n minus 1. Divide both sides by 2k and I get 52 equals n minus 1. So the number of terms is 53. Okay. And they can do things like this. They can tell you two different numbers in the sequence, but not necessarily the first and the second term. They could tell you the third and the 8th. They could tell you the 10 and the 20th. And rather than trying to work it out, you use your formulas. So you know the third term is 5, but that means 5 must be the first term plus 2 differences, because it's n minus 1 differences. We know the 8th term is 20, so that means 20 must be the first term plus 7 differences. And you've got two simultaneous equations. You're going to take the top one away from the bottom one, and you're going to get 15 equals 5d. So the common difference is 3. Okay? What's the first term going to be then? Well, if I substitute that into the top equation, 5 equals a plus 2 lots of 3, then my first term must be minus 1. So the common difference is 3. The first term is minus 1. So if the question then went on to say, what is the 50th term? You could work it out because now you know the first term and the common difference. Okay. And then it can get a little bit more complicated with the algebra. And this is the ones where they're really pushing your understanding of what an arithmetic sequence is. Because it says if A, B and C are 3 consecutive terms in an arithmetic sequence, show that. So I think, well, yeah, it's not telling me it's the first term. It's just telling me that they are terms in a sequence. So that's the situation I've got. They might be the first 3 terms, might not. I don't know. But what do I know about arithmetic sequences? I know arithmetic sequences have a common difference. So that means the difference between the term A and B is the same as the difference between the term B and C. Now, how do I work out what that common difference is? Well, the common difference between A and B is just B minus A. That's what I had to add to A to get to the letter B. What's the common difference between B and C? It's just C minus B. And now hopefully you can see if I add B to both sides, I'm going to get 2B minus A equals C. If I add A to both sides, I'm going to get 2B equals C plus A. So I end up with C plus A over 2. And that's what I wanted, because C plus A is the same as A plus C. So there we go. I've proven what the question asked me to prove. And we use that sort of thing with a question like this. So it does tell you now this is the first three terms. The first three terms of an arithmetic sequence are 12, p squared, and 3p plus 8. If p is an integer, find the first three terms of the sequence and the 20th term. So effectively, what I've got to do is find out what that p is. So again, I think, what do I know about an arithmetic sequence? I know they have a common difference. Well, what's the common difference? It's p squared minus 12. What's the common difference between the next two terms? It's going to be 3p plus 8 take away p squared. Now, be careful. If that had been something like, I'll do a hypothetical here, if that had been p squared minus 2, be careful when you're taking it away, you're taking away all of it. So be careful with this double negative here, okay? That's not the case in this question, but sometimes that is the case, and that's where people can make mistakes. So I've ended up with, 3p plus 8 take away p squared. And because it's an arithmetic sequence, the common differences are always the same. So I can say p squared minus 12 is the same as 3p plus 8 minus p squared. What is this? It's quadratic. How do I solve quadratics and make them equal to 0? So I'm going to add the p squared, I'm going to take away the 3p, I'm going to take away the 8, and I'm going to get 2p squared minus 3p minus 20 equals 0. Quadratic to solve. I want the factors minus 40 that add up to minus 3, and it's going to be, let's think, 8 and 5, and it's going to have to be minus 5 and plus 8. So I'm going to have my 2p squared minus 8p, 5p and minus 20. Take out the common factor of the first row, it's going to be 2p. So that's p, that's 5, and we have minus 4 on the end. So we've got p minus 4 and 2p plus 5 equals 0. So p equals 4 or p equals minus 5 over 2. Now it might have said find the two possible values of p, in which case that would be the answer. But in this case it said if p is an integer. So that means that is my value. That is not an integer. That's minus 2.5. So if p is an integer, I know my p is 4. Find the first three terms of the sequence. So it's going to be 4. Sorry, it's not going to be 4. It's going to be 12. P squared, which is 16. And 3p plus 8, which is 20. So that becomes my sequence. So my A is 12. My common difference is 4. So then the final part of the question says find the 20th term. So U20 is going to be A plus 19 lots of 4, because you do n minus 1. And that's going to be, so 4 times 19 plus 12 equals 88. Okay, so that's the type of thing you can do. I'm going to give you the questions here. So I'm going to do it like this. 5 questions. Press pause, and when you've finished them, press play again, and I will show you the answer. The one thing I will say about question 5 is be careful. K is an integer. So if you get an answer that's not an integer, you've made a mistake somewhere. Okay, so I'll show you the answers now. So the first one, fairly straightforward. Find out how many terms. You should have got n equals 41. And with the second one, hopefully you had n equals 30. Please tell me if I make a mistake with any of these. I do sometimes do that. Number 2, so again you're told the 4th term and the 9th term, so you can make these two simultaneous equations. And you should have got that the common difference was minus 4 and the first term was 10. And that meant that you could work out what the 30th term was with minus 106. Number 3, very similar. Okay, so you set up your two simultaneous equations. Should have got that the common difference was 5 and the first term was 2. Right, question 4. again, this is one of these questions where you have to realise it's an arithmetic sequence, so the difference is common throughout. Okay, so you can set up the minus p squared from this side is equal to p squared minus 15, and you get your solutions for p, and the question does say find the two possible values of p, so there we are, we've got it. And the final one, and this is where you've got to be careful with this one, because if you didn't accidentally do this double negative here, you'd have got a k that was something like 2.5 or something, I can't remember exactly, but it's not an integer. But again, you know that they have a common difference, so you can set up the 3k minus 3 is the same as minus k plus 13 to get your k equals 4. And in that case, you can write what the three first terms are using the equations here, because you know k is 4. And you end up with a first term of 4, a common difference of 9, and so your 50th term was 445. Okay, thank you.